between all these various things, let me just give you a little bit of background about myself. So I'm a professor at Melbourne University, obviously. What does that mean? That means that I'm old, basically. So the university has a lot of international experts in many different areas, ranging from law, arts, medicine, commerce, computing, engineering, and so obviously I'm the computer science department. And all these international experts do a lot of research, so I spend my time doing some research. I'm particularly interested in the human eye, so the number of retinal ganglion cells, that the nerve cells that are in the eye, how that relates to vision, how that relates to glaucoma. That doesn't really sound like computer science, probably, you're thinking, but there is actually quite a bit of computer science involved in that. I also do text analysis of political science texts. I used to do data compression and search engine algorithms. So Google uses some of my old work buried deeply in its operation somewhere. So at Melbourne Uni, there's lots of people like me who are experts in their field, and we do research, and so we also do teaching, of course, which is what you're more interested in to begin with, I suspect. So that's me. I noticed in the chat someone asked about actuarial studies. I actually originally studied actuarial studies at Melbourne University, and I graduated and I went and worked in insurance for a few years as an actuary. But I decided that wasn't the right career choice. Computer science would be much more exciting than actuarial studies. Actually, they're both pretty similar in a way, and I would have earned a lot more money as an actuary, but there you go. That was my life choice. So yes, you can study actuarial science at Melbourne Uni as well, because I did it. I was in the first year that it was offered at Melbourne Uni way back in the 80s. Anyway, let me tell you about computer science, data science, and what they all mean. My opinions, of course, but that's all right. I'm a professor. I'm supposed to have opinions on things, so I have some opinions on theirs. So let's start off with computer science. And computer science is kind of the basic building block for all the others in a way. Computer science is very much concerned with fundamentals of computation. What is computation? What does it mean to compute something? What does it mean to program something? What problems are possible to be able to be solved by a computer? Are there problems that computers can never solve? There is one, a famous one, called the halting problem, actually, which is kind of interesting. And so you almost get into philosophy in some sense, but it's all based on mathematics, typically discrete mathematics. And so if you pursue computer science alone, you often draw on strong mathematical skills, discrete maths, linear algebra, things like this. And of course, you learn how to program and how to turn, I guess I like to say, as a professor of computer science, I can program any computing machine to do anything, or I can prove that it can't be done. And so that's the kind of skills, if you're a really good computer scientist, that's the kind of skills you end up with. And the things that you might, if you just focus purely on computer science, computer scientists are employed in lots of big companies, small companies, all over the place. But fundamental computer science, you're doing things like building new programming languages. Who first invented Python? Excuse me. Some of you might know about the Linux operating system. Who did that? That was computer scientists. Who dreamt up Windows? Who dreamt up Mac OS? Who designed the algorithm that does route finding on Google Maps? Who designed the algorithm that works out whether your mobile phone switches between cell towers or stays with the current cell tower? All that sort of fundamental underlying software infrastructure is done by computer scientists. And there's another little project here, the greener cloud computing. This is a research group at Melbourne who, in addition to sort of working out how to put things in the cloud, so the cloud is like a big collection of computers spread around the world, that you can put data in and you can do operations on that data, but also having these cloud farms like Amazon, Google, Microsoft, etc., use a lot of electricity. And so how do you optimize your program and your software to use less electricity, hence reduce carbon emissions, hence save the planet? So that's computer science, and it's sort of fundamental, but you can take it into philosophy, you can take it into mathematics, or you can just learn to program. Once you've learned to program, it can lead to other directions. And a very popular one at the moment is data science. In fact, data science is almost a bit too popular as a term. People are starting to try and think of other things to call data scientists now. But the basics here are that you still need to know how to program, and you still need to know a bit of computer science. But you don't have to go off writing your own computer language. You don't have to go off working out what an operating system is. That's for other people. What you're particularly interested in data science is how do you ingest data, how do you get data in, how do you manipulate it, and how do you get results out again. So you can see in the graphic here, we've got this person with a graph, which coincidentally looks a bit like the COVID graph. In Victoria, we had a first wave and then we were okay, and now we have our second wave. So, but it's not the COVID graph, it just looks that way. So how do you generate graphs? How do you find meaning in data? So computer scientists are very good at crunching numbers. They like dealing with numbers and very abstract terms. But managers, politicians, media, decision makers, they don't want to see numbers. They need information. They need to see their data presented in a way that makes sense to them, and of course that is correct. So a data scientist uses their programming ability to crunch large data. So you don't want to be doing this sort of thing by hand in an Excel spreadsheet. You want to be writing a Python program, an R program, a Rust program to crunch through all your data, pull out the meaningful bits, and then create a nice visualization. So you need to be able to program, but you also need to understand statistics. So you don't want to go showing people information that may have just occurred by chance in the data set that you've got. And you need to have an understanding that sort of you're trying to communicate data to people. It's not just crunch a few numbers, work out the mean, pass it up the chain, and Bob's your uncle. Is that an Indian expression? Maybe not. Anyway, so programming, stats, and understanding the importance of trying to convey information from data. The next little step along this pathway is into actual human-computer interaction. So it's one thing to crunch some data and give someone a graph or some facts and figures. But what if that person then has to interact with the machine? So one of my pet hates are TV remote controls, right? So my TV remote control has like 50 buttons on it or something, which is ridiculous. I only use 3 of them. I turn it on and off, channel up and down, volume up and down, and that's it, right? Why don't I just have a remote control with 3 buttons? It drives me mad. So this is the type of things that user experience and human-computer interaction people think about all the time. When I write my software, when I write my marvelous new app to present data to management or alert people that they need contact tracing for COVID or to do online banking, what should I really be doing? How are people going to engage with that technology? What are they going to think? What are they going to feel? What colors should I use? How should I lay out the screen? What information should I present? So you have to know how programming works and how computer software works, but your emphasis is very much on the humans interacting with that technology. And this picture here, this is an absolutely amazing research project that was done here at the university. So this is an orangutan in the Melbourne Zoo. And in order to enrich their lives, we built computer games for them. So we couldn't give them controllers or anything because they just broke them. They're very, very strong. So we had to project onto the floor of their enclosure screens, and they would interact. So you project a dot, they'd hit the dot and it would explode, or you could get them to follow and chase. It was a truly amazing project, actually, that staff in our school were involved with. So that, and I've also got cybersecurity here on this slide. You're thinking, what's cybersecurity got to do with human-computer interaction? But there's a subtle link here. So cybersecurity is very, very important now that the world is connected more than it ever has been before, right? Power stations, hospitals, critical infrastructure is all connected in different ways. And I'm sure you've seen news reports about Chinese hackers, Russian hackers, you know, anonymous right-wing group hackers, all sorts of people trying to get control and steal data from people. So now that we're all connected, cybersecurity has become a big issue, and there's naturally technical solutions to cybersecurity, right? So having that really fundamental computer science understanding of how the internet works, what is TCP/IP, what is a packet, what is encryption, what's SSL, all of these deep mathematical sort of concepts comes into computer science. But there's another aspect of cybersecurity as well, where the most common point of failure is often the human, right? The thing in between the keyboard and the mind, the hands. So people give their passwords to others, they choose stupid passwords, all these sorts of things. So designing secure systems can involve sort of computer science and fundamental mathematics, but it can also involve a lot of human factors. How do you design these systems so that humans can't stuff them up, which they seem to do on a remarkably often. And then the next sort of piece in this puzzle, so we've got computer science, we've got data science, we've got user interaction with computers. These are all, I've been talking as though it's sort of one person, you're doing this by yourself. A computer scientist can build an algorithm by themselves, or I can write a game for an orangutan by myself. But of course, that's not true. Very big software projects require a team of people. You need designers, you need programmers, you need people to talk to your customers, you need lawyers, you need all sorts of people in a team to actually build a piece of commercial software. And you may or may not know, right, but Google, you know, thousands of employees, Facebook, Microsoft, Infosys and Tata Consulting over there in India, thousands of employees, all making software. How do you organize that? How do you get them all working together as a team? How do you engineer? So this is an engineering problem, right? How do you build a complex piece of software? So you can have your computer scientist writing the encryption algorithm. You can have your data science working out how the data will be presented. You can have your user interface expert working out the user interface. How do you get all these people to work together? There's almost a psychology kind of component to this, organizational psychology, management. And then when you do get them all working together, how do you deliver the software to the customer? So in my research, I only deliver to myself, and then I write papers about my programs, right? I very rarely, I've got a couple of open source products that I sort of maintain, but most of the code I write, I'm the only person that sees, no one else ever sees it. But in the real world, you have to worry about lots of people looking at your code. When Google employs new people, they have to be able to understand the software that exists. They have to be able to add to it. They have to be able to fix any problems with it. All of these things fall into the realm of software engineering. So you need computer science knowledge, but you also need management skills, you need communication skills. How do you work with large teams? How do you organize relationships, manage things? How do you document the software that you're producing? How do you write user manuals? All these things that go into a software product. And the main thing is you've got customers, which sometimes you don't in these other parts of computing. And then another area that is quite important, and again, if you're sort of following COVID news, you might have seen maps of outbreaks and hotspots and all these sorts of things. So getting data onto maps is an important part of computing, but also space. So spatial information can extend beyond the terrestrial into the extraterrestrial. So how do you map any space, whether it be outer space, inner space, whether it's a city, whether it's a country, whether it's the globe? How do you track bushfires? How do you track disease? How do you direct traffic? All of these spatial problems require a different type of mathematics. So you still need to be able to program and work out how be able to produce software, either as a software engineer or as a computer scientist. But on top of that, you need understanding of concepts around maps and surveying, GPS, all that kind of stuff. So recently, there's a project here at the university modelling flood damage, particularly around inner Melbourne. So climate change, we're getting hotter summers and wetter winters, although lately it hasn't been very wet at all. You should come and study here, it's really nice. Mapping floods, and of course in India with monsoonal floods and the like, that's important as well. We're sort of drifting now further away from computer science, and the next thing on the list, I guess, is robotics. So now we've drifted right over to a sort of a hardware end of the spectrum. So in robotics, you obviously have to be able to build stuff like this cool robot hand. So you have to understand electrical engineering, you have to know about circuits and how to put it all together, and actuators and motors and all those sorts of things, and new materials. So hardware and engineering. But of course, once you've created your device, you have to be able to program it. So usually computer science knowledge is used at first to work out how it could be programmed. But then if you're designing a commercial robot and you want to sell it, then it needs software that's can be sold, right? And this is where software engineering would come in. So the robotics part typically could be a lot of hardware, a lot of circuits, materials, and working out how to get the most, well, depends what you're going for. So this is a humanoid hand, but of course you can be very creative with your robots. They don't have to be humanoid. And once we've accidentally built our robot and accidentally programmed it with artificial intelligence and it takes over the world, we're in trouble. But for now, it doesn't look like it's going to happen. We're safe for the next 10 years, I think. But of course, AI is another buzzword. It often gets rolled in with data science, but it really is very, very separate. I think a lot of people talk about machine learning and conflate machine learning with artificial intelligence, when often machine learning is in fact data science. So looking for patterns in data and looking for information in data is a lot of machine learning. Artificial intelligence, on the other hand, is to try and mimic human intelligence. And so you can use machine learning as a basis for that, but machine learning is not artificial intelligence per se. And so we've seen self-driving cars being developed. We've seen assistants like Siri and Google, Nexus and things like this from Google. So it depends what you want to do with artificial intelligence. If you see yourself building robots and then programming, building humanoid androids, then you need your robotic skills and you need to understand artificial intelligence. again, built on computer science. So there's fundamental algorithms and data structures and concepts in computer science that underlie artificial intelligence. And then it's just a matter of having imagination and persistence to make it work. There's a whole bunch of other key areas in IT. So we've sort of covered the main ones, I think, here. I'm not monitoring the questions myself, but maybe others are, and they might have answered some of your questions about this already. But computing, I already talked about how everything's connected. Computing devices themselves are also ubiquitous, right? Mobile phones, smart watches, sensors in cities looking at traffic, looking at pollution, looking at light levels. There's more and more computers of all sorts of shapes and sizes everywhere around the world and being connected. So there's a phrase called the Internet of Things, where your toaster and your fridge and your lights and your whole house is connected to the internet, so you can play around with it while you're at work. Why you would want to do that, I have no idea, but I'm old, I don't understand. So because computers are ubiquitous, we've talked about the mainstream computing type of degrees and studies that you can do, but of course you can apply this computer knowledge to many other areas. Health is an obvious one, and that's a, oops, sorry, double click. That's an obvious one, and that's a strength of ours at the university, because we also have a very large medical school, and we're situated next to the Children's Hospital, the main surgical hospital, the main cancer hospital. So around Melbourne University, there's a lot of medical activity, and we have a very big medical school. And so computing in health is a big research area and a big focus for us. And likewise, bioinformatics, which is data science on human genomes and animal genomes, I guess is one way of looking at bioinformatics. But really what we're talking about here is CS plus X. So computer science plus something, whether it's computer science plus health, computer science plus biology, computer science plus ethics, computer science plus music, art, politics, human vision, all sorts of things that once you have a sort of computer science grounding, you can apply it to your passion. So that's about it for my rant. Hopefully you're all still awake. I can't tell because no one's got their video on, but I'll hand back now to Real to tell you some details about the Melbourne curriculum.
Thanks for that, Andrew. It was brilliant. I think you did an amazing job in really breaking down those different fields and how they all apply. So just before we get into our panel discussion, I'm going to give you a quick overview about how we do it over here at the University of Melbourne. And it all starts from that undergraduate degree. Now, all of you are between grades 10 and 12, I believe, at the moment, and you might have started thinking about what you want to do and where you might go to do that. And there's a number of different ways in which you can do this. You can start from an undergraduate degree and then go straight off, start working there. You can take it a little bit further and do a graduate degree following that and then go into the workforce. Or you can go and do a graduate research degree and follow that into your career. Now, if you want to really come to the University of Melbourne, the next slide has a bit more of an overview about that. It's talking about the, Andrea, if you wouldn't mind switching across. This is just going to be talking about the, I guess, different ways to go. And for most of you, you're going to be in that school leavers bracket up the top. Now, if you want to come to Melbourne Uni, I would recommend. It's the Bachelor of Science, the Bachelor of Design, but you're not just limited there. You have IT as a breadth subject, something you take out of your specific major in any of our degrees. There's a Diploma of Computing where you might take a little bit longer, but you come out of it with that extra knowledge and expertise. Or look, if you decide that you don't want to go to Melbourne Uni straight away, you can go to a bachelor degree from any recognized tertiary institution. And if you decide I think I want to take this a little bit more. I think I want to explore this a bit further and really dive down. Then we have our graduate coursework options there. There's the Master of Engineering, Information Systems, IT. There's all these different options for you to explore your studies. And from then on, you can go into your employment as a professional, or you can take it further into research. But I think something we're probably all a bit more interested in hearing about is from our panel members. And now I'd like to take the opportunity to introduce them to you one by one. So first of all, Professor Turpin, you've heard him speak for the last 20 minutes. He's brilliant at what he does. He understates how good he is at everything. But somebody else we have as well is Wandita Bhargava. She's the head of our India office, and she's based out of Delhi. Her background is actually from Melbourne Uni though. There's myself, who you've just barely gotten to know. We also have Lucas Fern, who's currently completing the Bachelor of Science, majoring in data science. Thanks for joining us. We have Lavanya Sivagurunathan. She's doing the Master of Engineering Spatial. And we also have Siddhesh Mandlik, who is no longer a current student. As of Monday, Sid officially graduated. Congratulations, mate. And that brings us to the start of our panel discussion. You've submitted a lot of questions so far. Thank you for that, people. And we're going to try and get to as much of those as we can. But first off, let's start with Lucas. Do you want to just tell us a little bit about yourself?
Yeah, sure. Okay, so I am a second-year student. I started the Bachelor of Science, and I hope to major in data science. If everything goes on track, I'll be graduating at the end of next year. So far, I've studied focusing on mathematics and statistics and getting in foundations of computer science, because before I started uni, I hadn't had any computer science studies. And yeah, in the future, I hope to further my knowledge in statistics and graduate the Bachelor of Data Science.
I'm sure you will. And moving on, Lavanya, do you want to tell us a little bit about yourself?
Hey guys, so I'm currently a fifth-year student at the University of Melbourne. I completed my Bachelor of Science, majoring in Spatial Systems, and now I continued through with the Melbourne model and doing Spatial Systems as well in my Master's, and should be graduating at the end of the year, hopefully, if COVID permits me.
Fingers crossed.
Yeah,
I'm sure you will. Excellent. And last but certainly not least, Sid, how about you?
Hi everyone. So I just graduated with a Master's in Information Systems with specialization in Business Process Management, Information Systems Strategy and Governance, and also Information Security Management. So like my course provides a healthy blend of business and IT knowledge, and it sort of helps bridge the gap with these two domains which the industry is currently facing. Prior to this, I did my bachelor's in IT, where I got exposure to computer and network configurations, web and application programming, and also database design and maintenance. So yeah.
Brilliant. And I guess with the follow-up question for all of you, and we'll go reverse order this time. So Siddhesh, you're up next. What do you want to do now that you're a graduate?
So now the main thing is now I want to apply what I've learned and gain hands-on experience in helping organizations achieve their vision. All organizations have a business strategy. So like the whole concept of aligning business strategy with what IT can do for them is what information systems degree has taught me. So just sort of applying what I've learned in my coursework in the industry is what I'm keen on now.
Brilliant. And Lavanya, spatial engineering, what's that got for you?
Well, I'm actually currently working as an engineer in the field, and I work in infrastructure as well. So a lot of my work kind of involves with urban planning and whatnot. Some of the technologies that we like to use within spatial is going into GIS, which is Geographic Information Systems. It's kind of a mapping tool for us to perform like complex analysis just right on my screen instead of actually going on field. And an area that I would really like to go into is digital twins. If anybody does not know about what digital twins is, please ask in the chat and I can give you an additional one because I would go on forever of what twins is. But yeah, being in spatial as well, understanding it's a mapping environments, a lot of our efforts are now being shifted to COVID mapping and doing COVID related analysis of like spread analysis, understanding what the community spread is, and all done through data science.
Brilliant. And Lucas, you're in your second year, you said, so maybe a little bit early, but have you given much thought about what you want to do after this?
Yeah, it is a bit early. There's still a fair bit of study ahead of me. So once I have my studies in data science, I'm considering maybe further studies in either business or some kind of psychology, studying the brain, because I'm interested in neurotechnology and have been inspired by efforts of some companies, especially to make devices like brain-machine interfaces, which is something that I would be passionate to talk about if someone has questions about in the chat. So that's sort of my long-term goal, but there's a lot of studies in the way of that so far.
No, I'm sure you'll nail that along the way. So look, we've had a lot of questions come through the chat already, and our team's already working away hard at them. But I've got a few which I might ask some of you. And first of all, I might actually switch to Wandita. If anybody's thinking of applying to some courses at Melbourne Uni, when should they apply by?
Thanks, Rahul. So ideally, the best time to apply is once students have got their pre-boards done with. So if you're looking at applying in July next year, say 2021, then the best time to apply would be around November, December, once you've got your predicted grades with you. You don't really have to have your English language proficiency test in front of you, so that can be given later on. But ideally, if looking at for the July session, then December, January is going to be the best time to apply.
Excellent, thanks for sharing that. And this one's for all of our panelists, and it could be a bit of a divisive question, but which is the best programming language? And I think I'm going to put Professor Turpin on the spot because he's the expert here.
Well, it's horses for courses, I guess. So if you want to whip up something quickly to quickly analyze some data, then Python or R are both very good for that. If really value efficiency, so you're building a robot and you don't want to drain the battery with your program, then you might like to use something like C or Rust, which is a newer language that's a bit safer and less explosive than C. You can shoot yourself in the foot with C quite a lot. If you want to write an application that's portable across lots of different platforms, you could try Java if you're kind of a masochist. But yeah, so horses for courses, I think.
All right, for the rest of the panelists, I'll change it then to, if you had to pick one, do you have a favorite programming language? And I reckon, Lavanya, you look like you're ready to share something.
I guess it's exactly what Andrew says. It's always course by course. So as Spatial, we love our Python. But it's also, it just depends on what we're doing, because you can do analysis on R and Python and everything. But Python so far, the easiest.
All right, that's a vote for Python. Sid, what do you reckon?
So the domain which I'm interested in, it involves a lot of getting information from databases, and Python is something which is pretty useful in that. So yeah, my vote goes to Python as well.
And Lucas?
Yeah, I have to also get on the Python train, just because whenever I have something that I can't do in Python, I go to my search engine, type in what my problem is, and it turns out I've just written the line of code into the search engine, because writing in the language is so much like writing in English.
Excellent. And before you started studying in data science, you said you hadn't done much computer science stuff, right, Lucas? So how did you start learning? Was it just through classes?
Yeah, so I had some, in the lead up, once I'd accepted my offer to Melbourne Uni, to figure out what subjects I wanted to enroll in, if I wanted to go down the path of computing, I spent maybe a week finding online resources, teaching myself really fundamental concepts in computer science, and I found hey, I enjoyed this stuff. I'm going to enroll into Competent 10,001. And that course was excellent. I would recommend it to anyone who wants to get a taste of computer science. And that made me want to follow it for the rest of my degree.
Excellent. I think, Andrew, we had a very specific question here about if somebody's a year 10 student and they've got a little, they want to start learning a little bit of knowledge, are they better off trying to learn some like multiple different languages, or should they try and, pick one and go, or what would you recommend if you're at that stage?
It's a bit like, well, there's a couple of things. I think you want to try and do something that you're interested in rather than just learning a language for language sake. It's like learning a natural language, right? I can learn Japanese because I'm going to travel to Japan, but learning Chinese just for fun is not going to work for me, I'm afraid. So it's a bit the same with computer. If you want to try and make a game, then you could try something like Scratch. If you're a real beginner into computing, there's languages like Scratch, or if you have an Android phone, there's a platform called App Inventor, which lets you write your own apps very easily. They're really good ways to sort of get into, and fun ways to get into the concepts of programming. And then if you want to take it a bit further, I think Python is probably the obvious next step. Yep.
I will admit, last week I was a little bit bored and I found an app in the App Store to learn Python, which I've started doing just for a bit of fun. You have a lot of time in front of screens at the moment, and so I thought I'd give it a go. So I'll check back in and let you know how I'm going with Python myself. We've also had quite a few questions about the slides that were previously shared. This is being recorded, so it will be available online afterwards if anybody wants to check that out. And there's been some questions about the, studying computer science and IT while studying commerce. And that is something that our India office will be able to go help you out with a bit more in depth, maybe after the webinar. But there's, I guess, breadth subjects. Maybe that's something that Lucas and Lavanya can talk about, how breadth subjects work, because you can take some IT studies as breadth if you're not in a Bachelor of Science degree. You can also do something called Diploma of Computing, which you can find information about online or by contacting the India office. But Lavanya, do you mind if I ask you a bit about breadth subjects and what they are?
Yeah, for sure. So I was really confused about this as well. So I'm an international student, so we had no idea what breadth subjects were. But I think having breadth subjects with Melbourne Uni was one of the best experiences that I've had, because not only did I have to pick subjects that were within my course, I can pick subjects that are outside my major and even outside of my course completely. So I could have done something from Bachelor of Arts or Commerce or Science or IT or Design. Personally, for me, during my undergrad, my bachelor route was in law. So I did engineering and law at the same time. However, with breadth subjects, you kind of, on your transcripts when you graduate, it's only whatever your major is. However, if you would want to do a diploma and have like a double degree or whatever, then you can do a diploma in like IT or computer science. And that way it can help. It'll just be an additional year.
Cool, excellent. And I think something that's related to that as well is that, let's say, you were studying commerce and you thought, you had one subject which you took in programming, you thought, this is really cool. Well, what you can do through Melbourne Uni, for example, is study that, have that programming that programming subject done, and then you can come and do one of those master's programs. But you guys are in, the audience watching tend to be in year 10 to 12, so it's a little bit further ahead. Lucas, anything you'd like to add about breadth, or do you reckon Lavanya's got that covered?
Yeah, mostly covered. You get to take a handful of breadth subjects. I personally took mine in economics, but no, not much to add to that.
In fact, talking about subjects in general, I'm going to ask you all, have you had a favorite subject that you've studied? And it doesn't have to be related to IT in particular. And I'm going to make you pick one. I know it can be hard, but you're going to have to pick one. And let's start with Lavanya.
Oh, this is actually very, very hard. Because some of my breadth subjects was not only in law, they were also in music. So did African drumming one semester. That was a lot of fun. But I think the subject I really enjoyed the most was disaster resilient cities, which is a subject that goes on. It's more of a theoretical aspect and studying like the theory base of how natural disasters occur around the world, and how, especially within my field, this is kind of what I'm very interested in, to go into post-disaster mapping and using like real-time information and real-time data analytics to like help our mapping processes. So I thought that was very interesting. I think one of the good takebacks from that class was that there's no such thing as a natural disaster. Every disaster is man-made.
Good to know. Sid, do you have any classes in particular that you would call a favorite?
There's one subject which I had done. It was service management and innovation. So it was like, it's a lot more theory-oriented subject, but it had a component where we had an industry partner and we had to work on their actual problem, which the employees are working on. So just applying the theoretical concepts which are taught in the lectures and sort of applying that to the practical issues was it was a nice experience. It's something which one of the highlights of my coursework.
Awesome. And Lucas, I'll make it a little bit broader as well. Favorite subject you've taken so far, or one you're looking forward to?
I'll go with one I've taken so far. Last year, Comp 10,002, there, at the beginning of the subject, learning C was grueling, but the lecturer, Alistair Moffat, and Andrew, I saw you'd co-authored some papers with him, I think, so you pass on my compliments, but he was excellent and made that subject so entertaining that has been my favorite subject so far.
Brilliant. Oh, yes, sorry, Lavania's jumping back in here.
Yeah, just wanted to add on to Lucas. Alistair Moffat is definitely one of the people who inspired me to do programming. I had no idea how to do coding at all, and I only learned coding in probably my second year of uni, and it was through Alistair's lectures, and he kept it very interesting, and it was good to follow.
I'm really glad to hear that. I'm sure Andrew will pass that along as well. No pressure. I'm going to just wrap up with a couple more questions. And look, we've had a lot of questions come through. Anything that can't be answered now, you can submit an inquiry to us afterwards via our website. I'll share all these details afterwards, but just going to wrap up with a couple more fun questions. What have you enjoyed the most about your degree? And we're going to put this outside of classes. So I think, Sid, you haven't started first for a while, so why don't you head up?
So apart from just studies and there are a lot of events and things happening around the uni itself. There are a lot of societies where you can just be a part of, attend events, and you just get to meet a lot of people, and that just enriches your overall uni experience. So the last 2 years I've had in Melbourne Uni, all of them have been amazing. Every semester you get to meet new people, and it's very rewarding. Not just apart from that, now I've finished my course, but I'm still in touch with a lot of people, and not just from my lectures, but even places where I've volunteered. You do build relationships, and that helps you later on as well.
Excellent, good to hear. Lucas, what do you enjoy the most?
Sure. I think honestly, one of the most enjoyable things is just how pretty the campus is and the location of it. Yeah, I mean, a couple of you have the campus set as your backgrounds. There's so many locations that are so beautiful and have a lot of history that, yeah, I just enjoy exploring it. And yeah.
Excellent. I actually, by the way, I studied at Melbourne Uni a long time ago as well, and I'm now working here again. So, I've come back and I've seen this campus for a long time. I think it's pretty awesome. Lavania, your favorite part about, I guess, your degree in general?
Oh, my favorite part about, I think this is just studying at Uni Mel in general, is because I think one of the best things that I got involved in were MUSEX, which is a Melbourne Uni Student Exchange Society. And from this society, I made so many friends from all over the world. And these are all like actually lifelong friendships that I'm always going to have. And I think last year during my summers when I traveled to Europe and I traveled to America and Canada, in most places, I would definitely always have someone to see and someone who's going to host me or show me around. So I think that Melbourne Uni being one of, even though we're so far from the whole world, Melbourne, but it's one of the most diverse places you can ever find. So I think just having really good friends, lifelong friends all over the world has just been great. It makes traveling a lot more fun.
Good to hear. And now potentially the most important question. What's your favorite food to get takeaway or to eat out in Melbourne? I love my food. And so I believe very strongly in this. And I'm going to ask Andrew to start us off.
Sorry, I wasn't listening. I was answering questions in the chat. Was that favourite food in Melbourne?
Favorite food in Melbourne?
I'm going to go with Japanese, I think. There's lots of good food from lots of different places, but I'm partial to a bit of Japanese. How
about Lucas?
Yeah, Andrew's stolen it from me. Japanese was definitely at the top of my list.
Sudesh, any particular favorites?
I would go for Italian actually.
Mm-hmm. Yeah, that's good to know. And Lavanya?
I'm originally from Malaysia, where we have the best food in the world, but Melbourne comes so close to it. I can't have a single cuisine that I like, but one Australian cuisine that I love the most is Asian fusion.
Good to know. And I mean, I agree with everything you say apart from Malaysia. Sri Lanka is obviously the top. And Wanzita, you've been to Melbourne, I believe. Do you have anything that stands out?
I think so. I've found so much of variety, in terms of food in Melbourne, that it's very difficult for me to pick one. Whatever you want, whether it's Thai food or, even Indian, there's so much of Indian food around the campus, and it has got all the flavors that, students would probably want to taste, while they're away from home. So yeah, pretty much Indian is quite good in Melbourne, and so are all the different cuisines out there.
That's great. Well, I think that's the end of our question time. I've got a few more things to wrap up with, but from our panel, I think that's it for you tonight. Thank you so much for being involved. I'm sure that everybody took a lot out of that today, and I look forward to working with you all again soon. Thank you. I will switch on to my slides now. Just to finish up, that might have been the wrong. No. Sorry, Andrew. Okay, if you can just tell me that I have the correct slides up now. Does that look right to you? Excellent, cool. So how can you get involved moving forward? And we've got a few things going on. In September and October, we have the hands-on entering IT. These are normally some workshops that we do in campus, but with the current situation, they're going to go virtual. We'll be providing those details to our India office, which you can get in touch with them about. We've also got the Amazing Spaghetti Machine Contest International. This is one of the things that I like to work on, and it's a contest you can take part in from home. You work in teams with some of your schoolmates, and it's all the details about it are available online. Again, our India office will be able to share that information with you. And then all I can say to finish off is, if you'd like to know more, if you'd like to get some of the questions that we might not have time to answer, you can go to our website at study.unimel.edu.au, connect with us there, talk to us, ask us any questions you want. We're more than happy to help out with that. And yes, thank you for joining us tonight. Thank you to our panelists and Professor Turpin. And we hope to see you here one day. Thank you and good night or good afternoon.